Hello, welcome. We're going to do a short video on functions. So we've heard that term function kind of traveling through the math map journey. And so I just wanted to touch a little bit on it of what it means, like what some of the notation means. So you probably caught on, or maybe you haven't yet, that this notation means f of x, which stands for function of x. And it can be very intimidating for a lot of students when they enter algebra and pre-calc and calculus. They see this and they don't know what that means. So I just wanted to kind of touch on it and show you a fun example that hopefully everybody can understand of why this curriculum is really cool in helping the kids visualize things. So you're seeing this a lot. I'm seeing it even in the naturals that my 5-year-old is doing. And there's like this little box in the middle and it's giving something like x squared, or it depends on the week. If it was multiplication, it'd be like 3x. Post division, it's x over 3, whatever it is. It's showing some operation. This week I'm personally doing the exponential unit, so there's exponents going on. But let's just look at it. So then you'll see where there's numbers on this side. So let's say we did 1, 2, and 3. And then there's numbers over here. So those numbers are coming through this little, what I like to call a number machine. So we call this the domain. Domain relates to X. Now, it could be a different variable meaning letter. It could be a different choice of letter depending on the problem, the mathematician, the style of math. But we're just going to stick with X's and Y's, okay? So X's and Y's, and that's where you're going to get to. So this is traveling somewhere as we're moving through. We're doing one-dimensional now. We get into two-dimensional, and you see where there's X and then there's Y. Y is your vertical, X is your horizontal, and all of these mathematical equations can be represented by graphs. So that's the ultimate goal. And much of higher math is all connected to these graphs, different features of the graphs, because they can tell us about all kinds of things in real life, whether it's, science, whether it's, economics, whatever it is, maximums, minimums, just what's a good one? You have interest rate, simple interest, and then compound interest, and then you have continuous interest. And continuous interest that we all get, in our loans, or our if we're investing, those different things, that is all calculus. It's a calculus concept to have continuous interest. And it's actually a very simple formula that was derived from calculus. But anyway, I'm going off on a big tangent, but I just, so many times you hear the term, when am I going to use this in real life? And let's be real, we have a lot of technology, but I could also say you can go in the gym and do a bicep curl and say, when am I going to use this in real life? Well, nowadays, you're probably not. Nowadays you're probably not going to have to deadlift 200 pounds. There's now, you might be faced with that and then wish that you had worked out in the gym and prepared yourself. But, with the modern technology, we have kind of limited ourselves and our understanding of how things work, and we just kind of want that fast-paced result. And that's what I love about the classical model of education, is it's really helping our kids strive for more. They want to know the why. They don't want to just say, "Oh, there's the quick answer. I'm just going to have it and be good with it and accept it." And some things we do have to just accept on faith. Like if you watch the video on the imaginary number, it's very important that sometimes we can also accept things by faith that they work, but we also recognize that that's because they are above us in our understanding. So, but there are things in math that make perfect sense. It just takes a long time and background to be able to build up to it. And those who develop the technology and the really amazing things that we have available to us nowadays are, at one point it had to go through a mathematician or a calculator that was designed by a mathematician. So there's a lot of relevance to this stuff to the real world. Right now, we're not going to go into all that, even though I went on a big long tangent, but we're just going to talk about this little number machine called a function. And your function, f of x, what we do is we just take numbers and we throw them in. And we say, okay, if I throw a 1 in and the little machine does a square, it squares it. Out will come 1 again because 1 squared, 1 times 1 is 1. If I throw my 2 in and then I square it, out comes 4 because 2 times 2 is 4. If I throw my 3 in and I square it, out comes a 9 because 3 times 3 is 9, and so forth. Ooh, that glare really hit hard all of a sudden. Let me switch this up. So hopefully you can see it a little better. Hopefully you can see that well. I have to get curtains for my little classroom in here. So it's really bright, but it's also not too good for videos. So we have this just basic illustration. This can be like infinitely many possibilities for functions. But this is just a basic example. But this is what they're trying to get to, because from this, we pick these values and out comes a value. Input, output, domain, and then this we call range. And you've probably seen that written in some places on the math map, whatever level you're using. They're doing these just more basic than others depending on the level. So range corresponds to y, and y is like, your dependent variable. Your independent, we throw it in, and then out comes another value. So that's basically all I'm going to touch on with this. But know that, in the future, they're going to see stuff like this in algebra. So f of x equals x squared. And they, depending on the level you go to, you might have to calculate what's f of 1. Well, f of 1 is just throw a 1 in. 1 squared, and it equals 1. It's exactly what we did up there, but this is the mathematical way. This is how we would follow the process. If it was something more complicated, we would do the same thing. So just know that as they're working through these problems, there is a reason behind it. But I felt like it's such an important concept for them to grasp. I figured I would do a short video on it so you could see what exactly is happening with functions, domains, ranges, and all this stuff going on. Know that it's going to get really awesome once they hit 2-dimensional and 3-dimensional, and you'll see the visual of how this stuff all comes together. But there's your little, quick tutorial on it. And that's what it is. You just plug your number in and out comes a value. And for the higher level, for, the complex, you might see stuff that's a little more complicated, and just know you're just plugging that value in for this and seeing what does it become. It's a little machine. Throw it in, it transforms, it comes out. And kids love that kind of stuff. All the superhero shows, all that stuff that you always have your basic kid, and then they pop in the little whatever it is and they transform into something different. And this visual is so clear cut for them to see. That's all this is when they get to these higher levels of math. And it's truly the foundation of all, higher level mathematics is all about functions and the graphs from them and the applications. So there you have it. Have a wonderful day. Thank you for joining us, and we'll see you later.